Here in this video, we would like to talk about the rated power, and of course later we will talk about the used power. First, let's talk about the rated power. Whenever there is an electric device available for you like a bulb or fan, that device will have a rated voltage and rated power. Means what? When you send that much of the voltage to the device, it will deliver that much of the power. So we can write a formula. Power can be written like energy by time, and energy is nothing but work done. Work done is nothing but equal to VQ by time. That's equal to VI. But we can write further I as V by R using the formula V equal to IR. I can be written like V by R. So V by R, that is V square by R is the formula that we can use. So we can say power rated is equal to voltage rated square by resistance. So we can use this formula to find the value of the resistance. So if somebody wants what is the resistance of that, we can say voltage rated square by power rated. We can use this formula to calculate the resistance. We can also use the formula power is nothing but equal to VI. So if somebody asks, I can further write P rated is voltage rated and I rated. Using this formula, power can be written like VI. So if you want to calculate what is the current rated that will give an electric device, we can calculate it as using a formula power rated divided by voltage rated. So if someone say that there is a bulb of voltage rated 240 volts, power rated 100 watts, we can calculate the resistance of that using this formula voltage rated square by power rated, that is 240 into 240 by 100. If you calculate, you will get that value as 576 ohms. That we can do. Further, if you want to calculate what is the current rated, I can write the formula I rated is using this formula. Power rated is 100 watts in the problem. Voltage rated is 240 volts. So it will give you approximately some value of like 0.4 ampere. So using these rated values, we can calculate some of the data like so. But in many times we don't connect the device to the rated voltage, but rather we connect the voltage to when device connected to different voltage than the rated voltage, utilized voltage, then it delivers a different power than the designated power because its resistance is always a constant. In that case, we can write a formula as, in the place of say power, I can say power developed or utilized as voltage utilized square here by resistance, because resistance is constant, right? So we can calculate how much of the power utilized when a particular voltage is given using a formula that resistance is constant. From here I can write a resistance formula as voltage rated square by power rated, that is equal to, from here I can write a formula voltage utilized square by power utilized. So if you want to calculate what is the power utilized, I can just get this term to this side. So what you can say, power utilized is equal to voltage utilized by voltage rated whole square and power rated. That is how we can solve the problems, right? Some simple problems basing on these concepts. So be careful. From here we can say that if voltage increases by a certain percent, the power, we can say power is now here directly proportional to V square. Using any of these equations we can say. So we can say delta P by P is 2 into delta V by V if it is approximation. But generally that's not the case. So if somebody say if voltage is increased by 10%, then I can write power utilized is directly proportional to, or P1 by P2 is equal to V1. Power utilized is equal to V1 by V2 whole square. That is V1 is V, V2 is 1.1 times of V whole square. That is 10%. 100% plus 10% is 110%. 110% is 110 by 100, that's 1.1. That's 1.21. It implies P2 becomes 1.21 times of P1. That means delta P is 21%, from 100% to 121%. This is how we can calculate and solve the problems. Thank you for watching.